left an exercise up for those of you who wanted to get a little extra practice in on the break. This was just choosing a number, checking to see if it's even or if it's odd, and then responding accordingly. So in this case, to check for if a number is even is to check and see if the remainder of that number divided by 2 is equal to 0, in which case we can put that as a condition in a branch and print even if our condition is true. And if the condition is false, then we can have an else statement and print that it's odd. And then there was a little extra credit as well, responding to if a number is divisible by 4. Again, the remainder being equal to 0, in which case we'll print that message as well. And then the second bit of extra work was to actually specify a second number and check to see if the first number, here called num, is divisible by the second number, here called check, and then printing messages accordingly. So when I define num is equal to 3 and check is equal to 4, and then I look at my outcomes, I see that num is odd, and I'm printing not by check when my first number num is not divisible by my second number check. So if you did these exercises on the break, maybe your code looks something like the one I wrote up here. All right, so I'm going to clear my script. Let's finish out the content for module 1, and that is progressing more into capabilities concerning control flow in our software. So we've done the if-else statements, defining code that is only executed upon evaluation of certain conditions. Another capability that we have in Python is to specify that a particular block of code is repeatedly evaluated according to a condition as well. So we can use a keyword called while and say that while some condition is true, a particular branch of code should be executed repeatedly, where after every execution of our code, the condition of our while block is evaluated again. And that while block will continue to be evaluated over and over and over until the condition evaluates to false. So I can say something like this. Say I have some integer a equals 1, and I can say while a is less than colon, just is no longer less than 5, and I'll say is equal to a plus 1. So the value of a is increased by a value of 1 at every evaluation of this branch. The shorthand way of typing this is a plus equals. Those of you who aren't familiar can also create comments in your code using the pound. So everything followed by this line, you'll see that in my IDE, this is grayed out. So this is a comment. And these two are the same. A equals a plus 1 or a plus equals 1. Those are the same thing. And now at every iteration of this block, the value of A is going to be increased by 1, and this will continue until A is no longer less than 5. And now we get out of this branch in the same way as with our if blocks. So we just return and go back to our original level of indentation, which is 0. And then let's just print A. So A is equal to 1 while A is less than 5. Increase the value of A by a value of 1, and then print A. And when I execute that, I find that the final value of A is equal to 5. Now we can see this in action by going back into this branch and say, let's do another print statement that says a string inside colon, and then again we can print as many things as we'd like inside one print statement. So we can do inside colon and then do a comma and then just print A. And when we execute this, we see something like that. So started at 1, went into our branch, increased A by 1, and then printed A, and we got inside 2. After that execution, the condition is then tested again, is A less than 5? Well, that was true, and so we do it again, and so on and so forth until our condition is no longer true. And then the code continues on. Now there's a faster, or not faster, a more abbreviated way of doing this with another set of Python functionality, which uses the keyword for. And for does a lot like what the while branches do, except that for can be much more specific as to what to actually iterate over. So in this case, when we instead start by saying for, we can declare some new variable. In this example, the variable's name is n. And say that our variable is going to iterate over a set of numbers, and we can generate this set of numbers using the function range. This is built in to Python. And when we say range of 5, range will return every integer starting at 0 up to but not equal to 5. So when we say for in range of 5 and then a colon, this branch of code that we specify in here will execute for n is equal to 0, then n is equal to 1, equal to 2, so on and so forth, until n is equal to 5. And when n equals 5, the code will return back to the software in the preceding level of indentation. So in this case, we can do something like for in range of 5 and just print n. Now we've essentially done the same thing as what we had done before of say if we had done a is equal to 0 and while a is less than 5, print a and then a equals a plus 1. this will print 0, 1, 2, 3, 4. And then when testing for here, we try to do a is equal to 5. The evaluation returns false, and this progresses into the next lines of code. Done the same thing here. Now this is a very limited example of a much broader set of functionality concerning for and using for to iterate over things. But we're going to reserve that for a little bit later mostly. But in general, this is how you can do iterations in just one line of code over some set of integers. Now range has some additional functionality. So when we here pass just a value of 5 to range, as I said, the default behavior is to iterate starting at 0, do n equals 0, n equals 1, equals 2, all the way up to, but not equal to the value that was passed to range. Now, if we specify 3 arguments to range instead of 1, we can specify the first value in the iteration, and that here is denoted as start. So when we only pass 1 argument, start is equal to 0. But when we pass 3 arguments, we can first start by specifying a starting value of our iterator, which is what n is called. The starting value, if we say pass first the argument 1 for start, n will begin by equaling 1, and then we can specify our stopping value of 5. So in this case, when we pass range of the arguments 1 and 5, this will iterate from 1, beginning at 1, through every integer up to but not equal to 5. So when we run this, now I see I only get 1, 2, 3, and 4, but not 0. Or 2 and 5, get 2, 3, and 4. Now the third scenario, this is the one that's actually listed here, is specifying the step in an iteration. So when we don't specify a third argument, then our iterator is incremented by a step equal to 1. At every iteration, n is increased by a value of 1, but we can change the integer by which our iterator is increased. And in this case, we can say specify a value of 2, in which case this will begin at 1, and it'll increase at each successive evaluation of our branch by a value of 2 until n would equal 5, in which case it stops. And so in this case, passing 1, 5, and 2 for start, stop, and step, n will equal 1 and then 3. And of course, other stuff in our branch. And you can test this out as much as you'd like. Okay, and so I'd like to just get James, can we do a check-in with everyone and see, make sure everyone is keeping up while we work through this example together real quick? All right, so real quick, I think we have one more person working. Let's just do this together very quickly. So we have two positive numbers, say A and B. Let's do A equals 100 and B equals 200. I want to sum every odd integer from A to B inclusively. And so we can do this a number of ways. Let's just do a very simple case. So let's do, actually no, let's not do a simple case. Let's practice our fours. So let's say we're going to declare a variable called result. And result is where we're going to store the summation that we're going to do over the range from A to B inclusive. And so let's just start by initializing that equal to 0. And now let's say in a for loop, let's say for in range. And let's use two arguments. Let's do, let's specify iterating from a starting value of A, being the beginning of our interval. And let's do up to our second value B, while handling that range will only iterate up to, but not equal to, our stopping value. In which case, to also iterate up to the value of B, we have to pass B plus 1. So for will iterate up to, but not equal to B plus 1, in which case the last value that will be iterated over will be B. And let's do a colon. Let's go into this branch, and we only want to do odd integers, in which case let's do a test to see if n is odd, and we can do that by saying if n, and let's find the remainder of n divided by 2. And if n is odd, then the remainder will not be 0. So if the remainder of 2, or n divided by 2, is not equal to 0, and let's add a colon, and in this second level of indentation, we'll add n to our result. Result equals result plus n, or in some shorthand, just result plus equals n. And let's get out of our if branch, and let's get out of our for branch. So we're going to go all the way back down to no indentation, and let's return a line, and let's just print our result. So for A equals 100, B equals 200, should find that result equals 7,500. So again, there are quite a few ways to do that. Could have specified a different step, could have specified different starting conditions, and moved the test for whether or not n is odd. Lots of different ways to do it. What matters is that the result is correct. So again, these slides will be made public to everyone after our sessions are over for today. So if you want to revisit this, by all means. Now, something interesting that we really don't get into all that much in CompuCell, but it's certainly possible, is how to actually terminate a branch that's being iterated over preemptively, something like an interrupt. So if, for example, I am doing some sort of while loop, beginning with A equals 0, and when I say while A is less than 10, and I'm going to do some stuff, including increasing a by a value of 1 at every iteration. Now, say for whatever reason, I want to actually break out of this branch early, as in before this condition is no longer true. I can do that using what's called the break keyword. Break will get out of a branch and return one level up in some hierarchy of control flow. So if, for example, I say declare another variable that says, I'll just make it a Boolean and say b equals true, just for fun. Now let's say that in our while loop, if b is true, and then if a is, say, greater than 5, then break. Or as a way to join evaluations of comparison operators, we can use what's called the AND keyword. And we can do that by just doing this. If b and a is greater than 5. This evaluation is a combination of both testing is b true and also is a greater than 5. Boolean operators also define OR in exactly the way that you would expect. If b is true or if a is greater than 5. We'll do, in this case, if b is true and if a is greater than 5, then we'll break. And let's print a and see what we get. So when b is false, this never gets evaluated. And we should get, yeah, a is equal to 1, 2, 3, 4, 5, so on and so forth. Now, when we set b equal to true, this will always return true. And so when a is greater than 5, then you see now, as we print a, once a is greater than 5, the break occurs and we get out of our iterations. So here's a comparison of using those two. Each of them has their own uses. I'll leave this to everyone to sort of think about a little more as we progress through the week and in their own time and in their own practice.